So we're going to look at Pearson's correlation coefficient, or as it's more widely known, Pearson's product moment correlation coefficient. And we're going to restate some of the stuff we did in the intro, but also look at how this is calculated and what it means. So Pearson's correlation coefficient, often written as R, is a statistic that measures the strength and direction of the linear relationship between two numerical variables. It can range from -1 to +1. So you can't have a PMCC which is less than -1 or one which is more than +1. +1 means a perfect positive linear relationship. As one variable increases, the other increases, always by the same amount with a +1. And as we've seen in the past, that means that your data would line up exactly along a straight line. -1 means a perfect negative linear relationship, and as one variable increases, the other decreases, but -1 again perfect like the +1. 0 means no linear relationship. So basically you just sort of get a cloud of data points with no trend to it at all. Now, I'm just going to say at this stage that you actually really don't need to know that much about this. I'm probably going to state more than you need to know, but it's helpful to have this as background. It helps in answering certain types of questions. In simple terms, it tells you how closely the data points fit a straight line when plotted on a scatter plot. And that straight line, the line of best fit, we're going to look at that slightly later in this work, not in this particular lesson. You are only expected to be able to calculate correlation coefficients using technology. However, we are going to calculate one manually below in the next example to give ourselves an idea of how it works. In simple terms, it compares how much two variables change together to how much they vary on their own. The basic idea is it looks at each pair of data points and sees how far each value is from the mean. When we look at the formula, we'll come back and look at this point. It multiplies those distances for each pair, so you see if they tend to go up and down together. It adds up all those multiplied distances. Then it divides by the overall variation in both variables, so the result is always between -1 and +1. So the formula basically says, how much do x and y change together compared to how much they change on their own? For a set of n pieces of data given as ordered pairs, x1, y1, x2, y2, xn, yn, and so on, R is equal to the sum of x minus x bar times y minus y bar divided by the square root of the sum of the x minus x bars squared multiplied by the sum of the y minus y bar squared, where x bar and y bar are the means of the x and y data respectively. So let's look at the points that we talked about above. X bar, y bar would be some point that we could plot onto a scatter diagram. Remember, x bar is just the mean of all the x values, and y bar is just the mean of all the y values. Then let's suppose we've got some point, call it xy, which we place on here. Where this is to the left and down from x bar, y bar. So this distance would be x minus x bar, and because it's to the left, that one would be negative. And then we'd have y minus y bar, and that would also be negative because it's below. We're going to the left and below x bar, y bar. So when you multiply x minus x bar, y minus y bar, you'd be doing a negative times a negative, giving you a positive. There'd also be a positive if it's up here, because then x minus x bar would be positive and y minus y bar would be positive. So when the points tend to be along this sort of region, you're going to get them both negative or both positive, and that means you're going to be adding positives on the top. Now, when you don't have a perfect correlation, you're likely to have a couple of points like this where you would get a negative result, but the bulk of them will give you a positive result. When you have a negative correlation, most of the points will tend to be like this, so that point here would give you x minus x bar as negative, but y minus y bar as positive. And then the product down here would be negative. And the same would be true down here. So that's how you get the positive or negative correlation, because if you look at the bottom, we've got squared quantities. They've got to be positive, which we're adding up, and then taking the square root. So the bottom of this is always going to be positive. Because the top is a mixture of positives and negatives, the top is always going to end up smaller, except in the case of perfect correlation, when the top and the bottom would be equal. Hopefully that gives you a bit of an overview of how this works. You don't need to know a lot of what I spoke about here, but together with the following example, when you are doing them on the calculator, at least you have an idea of what it's about.